All right, so we can't really get any further into this workshop without addressing magma because magma is a lot more complicated than you probably thought. It gets pretty crazy. So we know from the previous slide on Earth's interior that the the mantle is solid. The asthenosphere is solid. It's plasticky, but it's solid. The only part of Earth's interior that is liquid is the outer core, we believe. That's all from geophysics. But what that means then is, well, if only the outer core is liquid, how do we get liquid magma below the Earth's surface? How do we get liquid lava, erupting onto the Earth's surface? And to answer that question, we have to look at melting. Now, any material can be brought to its melting point by increasing the temperature, decreasing the pressure around it, or by changing its composition somehow to something that melts easier. And for magma, this means you either have to add heat to the rock, increase the temperature of its surroundings, that is. You have to release some of the pressure on the rock without decreasing its temperature. Or you can add volatiles like water to change the composition to bring the rock down to its melting point. Or you can do some combination of those three. But we know that magma is hot rock. And rocks, by definition, they're not individual minerals, but they're assemblages of many different kinds of minerals. And we know from previous slides, especially the igneous portion, that each mineral has its own melting point. So getting a rock to a certain temperature, pressure, composition may melt part of the rock, but may not melt, some other minerals may not melt the entire rock. And this means then that magma can and often does exist in a partially melted state. In fact, the magma chamber under Yellowstone, don't quote me on this because I read it a long time ago, it's around like 10% liquid and the rest is solid. So if magma isn't a liquid, what is it then? And magma is in fact a mixture of solid, liquid, and gas phases or portions. And the liquid portion of magma is most properly referred to as the melt. However, we do know that magma is mobile. It can move around the Earth's interior. It can move up onto the Earth's surface to become lava. So for magma to be magma, by definition, it must be free-flowing. And what this means is that for magma to be free-flowing, it must be between 40 and 60% liquid. Other than it, if it's not that, then it's just a bit of melt floating around in some rocks. And actually this 40 to 60% figure, it actually depends a lot on the composition as well, believe it or not, but we won't go too much into that today.